Hello, my name is Grant Kramer, and I am a professor at the University of Nevada, Reno. Today I'm speaking from the top of Saint-Emilion in Bordeaux, France, one of my favorite places. You can see this ancient city around me and then the vineyards, the outstanding vineyards in the area that produce wonderful grapes from the right bank. Today's lecture will be about the factors that affect grapevine yields. This is a relatively dense subject. There will be a lot of information in this video, so I encourage you to review it several times. But I would like to start off simply. Let's examine the composition of grapes. Basically, they're made up of 75% water, 24% sugar at harvest time, only 1% in organic acids, and the rest are miscellaneous metabolites and minerals. To make those components of the grapevine has essentially four needs. The need for light energy, obviously, and carbon dioxide to make photosynthesis, which creates and converts light energy into sugars. And it needs water, which makes up the bulk of the volume of the plant, as well as some minerals, largely to be essential elements for photosynthesis, but for other constituents in the plant as well. So let's get into the topic more deeply. So factors that influence the yield components are planting density, canopy size per acre, clusters per shoot, the cluster weight, the number of nodes per vine, flowers per cluster, shoots per node, berries per cluster, and berry weight. There's a lot to that. But how can we affect those factors? So planting density is determined when you plant the vineyard. So it's something that has to be thought out well in advance. Canopy size per acre is controlled by the trellis construction and your vine training. The number of clusters per shoot is determined by cluster initiation, which occurs in the previous season. The cluster weight is determined the year before cropping. The number of nodes per vine is controlled during the growing season or before the growing season by the pruning level that you use. The number of flowers per cluster is determined before bud break. The number of shoots per node is determined at bud break during the growing season. The number of berries per cluster is determined at fruit set during the growing season. And the berry weight is determined by the berry growth during the growing season. There's a lot to that, so let's break down some of that in the next remaining slides for this video lecture. So factors affecting vine vigor also affect yield and grape quality. And this is affected by your planting density, by something called vine balance, which is determined in part by pruning. These are terms that can be defined by the amount of leaf area per the amount of fruit weight. So the leaf area is determining the photosynthetic capacity of the vine and the production of sugars, and the fruit weight is determining the demand for sugar. So it's a source to sink relationship, a supply and demand relationship that creates that balance. The number of nodes, buds, and clusters influence that, as well as the shoot density. Again, I'll come back to these terms in more detail. The other factors that influence yield and grape quality are your water supply, the amount of irrigation if you're in a zone where you need to irrigate. That's determined in part by the depth of the soil and the texture of the soil, and then the nutrition of that vine. the accumulation of minerals. Are there sufficient minerals in your soil, or do you need to add some? Or are there elements that are in too high a concentration that can cause toxicity problems? Grapevines in general, I describe as growing like weeds. You need to do very little for them and they're able to grow. Obviously, if we want optimum yields, we want to make optimum conditions for our grapes. So planting density is the number of vines per acre. A low density can have the same canopy length as a high density vineyard. Those vines that are in a lower density just become bigger and can fill in the canopy. The trend was and is to plant higher and higher densities, but have less fruit per vine. So in the case of picture here, you're seeing a picture of grapevines that are on Cheval Blanc in the Bordeaux right bank region, a very famous winery. And these grapevines are planted within 1 to 2 feet of each other with very narrow rows, as you can see in the bottom corner here, using tractors that go over the rows with their wheels going down the rows. So this is maximum density in the vineyard. It used to be, and if you still go around in some places in the Central Valley of California, you can find vines that are 8 to 12 foot spacings, much larger vines. So row and vine spacing. Grapevines compete with each other for water and nutrients, particularly on poor quality soils. The deeper and richer soils, you could get closer and closer planting densities because there is less competition for the resources. There are more resources that are available. The row and vine spacing, however, can be limited by the field area that you have to plant in. And row spacing may depend on the tractor size, usually between 6 and 12 feet, depending upon the type of tractor that you have. In the bottom figure here, you can see the impacts that row spacing can have on grapevine production. Here on the left, we see the pounds of fruit per vine. And as the row width goes from 12 feet to 10 feet to 8 feet, we see that the number of pounds of fruit per vine decreases with decreasing row width. On the other hand, because you have narrower rows, you can plant more vines. And as a result, the amount of tons per acre of grapes increases with a decreasing row width, as you can see in this right-hand side of the figure. So studies have showed that decreased row spacings lead to increased crop yields per acre. Another important point here is that vine spacing is more important than row spacing. If your vine spacing is too close, individual shoots will grow too fast. If the vine spacing is too wide, canopy development will be uneven, resulting in yield losses. You can see images of this up in the upper right-hand corner where vines are too narrowly spaced versus optimum spacing versus too wide. And you can see the canopy begins to decline, and with reduced canopy, that you have reduced photosynthesis, and therefore you're going to get reduced yield. So optimum vine spacing will produce a balanced canopy, no gaps or excessive growth of the shoots. So I recommend vine spacing between 4 to 6 feet, depending on your cultivar and your growth conditions. So if you have more vigorous vines, you may want closer spacing. If you have less vigorous vines, you may want more distant spacing. But there's a balance to this. There's an optimum. Too far apart, not enough production. Too close together, and you suffer in terms of photosynthetic capacity versus the fruit quality. Let's talk about vine balance for a moment. Vine balance is defined as enough leaf area to provide optimum yields and to fully ripen high quality grapes. Vine balance is often measured as fruit weight per pruning weight or fruit weight per leaf area index. And leaf area index is the amount of leaf area per unit of ground that you're covering. Pruning weights are hard to do. You have to weigh out all the prunings in the time of pruning to get an estimate of how much pruning weight was produced in that year. This is sort of a destructive and labor-intensive process. So leaf area is another way to estimate this. Leaf area measurements have progressed in recent times with our digital cameras and drones. So there is a program called VisiCanopy. It's a useful free app that's available on iPhones or Android phones that you can use to calculate the leaf area index. And if you want more information on this easy method, go see an article produced in Sensors Journal by Bay et al. In 2016. And here I've listed the actual journal link if you want to read the article, or you can see a short video on YouTube that describes the use of this app on your phone. Vine balance is also determined by your optimum shoot density. So we were talking about vine density, now we're talking about shoot density. Balanced growth is necessary for the proper ripening of the fruit. It has been determined that approximately 12 to 15 shoots per meter of vine canopy, that is the length along your trellis, is needed for vine balance. Too dense of a canopy will result in lower fruit quality, and too loose of a canopy reduces your yield per acre. It's a little more complicated. So shoot number also affects shoot length. Too many shoots per vine capacity causes shorter shoots, which may not have enough leaves to be able to ripen your fruit properly. Too little shoots causes excessively long shoots, which will encourage lateral shoot development. And lateral shoots are not desirable. They tend to reduce the airflow and the light penetration into your canopy, which causes problems for disease as well as the quality of your fruit. Trellis design is an important way to control your yields. Highly vigorous vines may need a more expanded trellis system. The length of your canopy can be doubled or quadrupled depending on your trellis design. And that length of canopy will then increase your leaf area, which will increase your photosynthetic rate, which will then increase your fruit yield. Some examples of the increase in canopy by trellis systems are the Scott-Henry system, the Lyre system, or quadrilateral systems. There are many, many different designs of trellis systems to be considered. The most popular today is the vertical shoot positioning system, and I will describe these in a moment for a few of them, but there are many more to be considered. If you're very, very interested in this, there are pros and cons to each trellis system. I recommend that you investigate a little bit more with reading materials. This is not my area of expertise, but some people have devoted their whole careers to just developing and studying the impacts of different trellis designs on yield and quality of fruit. So the trellis design will impact your plant vigor as well as your fruit quality. Here are some examples of different trellises that are used in the California area. You can see the vertical shoot positioning system here. This is in our own vineyard at UNR, where the vines are trained with the shoots growing straight up. This increases fruit exposure. Here we have done leaf pull, so the fruit is very, very exposed in this case. But by lifting the vines straight up. It allows for better penetration of light into the canopy. It will reduce mildew because of the increase in light and airflow around the fruit and the vines. The vertical shoot positioning system is a more extensive set of posts with several wires. You have a base wire which the cordon is tied to, and you have several sets of wires up above it that you train the vines to grow between to keep them in this upright position. The sprawl is a simpler system in which there's a single wire for your cordon and another wire just above it in which the shoots are grown to hang over and drape over that wire as if it was a curtain, and then it hangs down towards the ground. This provides more shade than the vertical shoot position system, but is a simpler system and may be more suitable in hotter climates. And then on the bottom here, we have two split systems in which here we see the lyre where the vines are split. That is, they are trained to grow onto two different sides here. This doubles the surface area that the vines are growing over and increases yields. Another system which my mother uses, which you can see here, is a quadrilateral system where again the vines are grown and split out to grow either direction on either side. So these are just examples of different types of trellising systems to consider. Most people today are using the vertical shoot positioning system. However, it may not be the best for your particular conditions. You need to factor in your vine vigor. You need to factor in your temperature conditions, the amount of light conditions that you have to look at what particular trellis system may be best for your types of grapes. Okay, cluster initiation. So clusters take place, or the initiation of it takes place during the previous season at flowering time when the buds are beginning to form. Potentially, it determines the number of clusters per shoot, the cluster weight, and the yield. As I mentioned before, shade decreases fruitfulness, so it inhibits cluster initiation. There's a requirement for light which increases the ability of those clusters to form in the previous season. Pruning is a way of managing, as well as trellis design, the light in your canopy and therefore the fruitfulness of your shoots or your buds. Fruit set. So this is during the growing season. Fruit set is regulated by your climate and endogenous factors. So cold temperatures, hot temperatures influence fruit set. Cold temperatures inhibit it. Rain can inhibit it. Rain can displace the pollen on the flowers, and therefore there will be poor fertilization. Endogenous factors are referring largely to hormones. Gibberellic acid is the most important, and you need the right amount of endogenous factors, not too much, not too little, to get maximum fruit set. But another important factor about fruit set is sugar. Sugar supply is very important. So having good photosynthetic rates, which are controlled by the climate, by your canopy, by the number of leaves you have, this is all going to contribute to good sugar supply, which is going to allow for good fruit set. Likewise, set is higher when you have fewer clusters per vine. Why? Because when you have more clusters, you have more demand. More demand, if there's not enough supply, is going to reduce that sugar content or that sugar supply, and therefore reduce fruit set. So lightly pruned vines have low fruit set. The shoot tips compete for carbohydrate resources and needed during the fruit set. So when you do light pruning, you will get more shoot tips. And as a result of that, you may get more fruit, but the actual fruit set per clusters is reduced. This is what I was talking about before, where vines can compensate for the various conditions. You may get more clusters, but you may get less fruit per cluster or smaller berries per cluster. So berry size. On the right, you can see a picture of conditions that happened as a result of some cold temperatures, usually. Millerondage is the name of this phenomenon, or hens and chicks, or there's different names for it. But you can see that there are various sizes of berries, some that have been properly fertilized, some that are larger or smaller, depending upon the number of seeds in the berries. You can see more about this information about what controls berries development by going to my video from flowering to fruit set. There I go into more detail about the physiology of what is going on. So again, berry size is influenced by climatic conditions, but it's also influenced by genetics. Some varieties have larger berries than others. Some clones of the same varieties have larger berries than others. It's also influenced by other environmental conditions, such as the irrigation level. The higher the irrigation, the larger the berries will be to some extent. There's an optimum or a maximum. If you get too much water, of course, you're going to flood your vineyard and kill the vineyard. So that's not a good thing. But drought stress or water deficit reduces berry size, or can reduce berry size if it's severe enough. And this impacts berry size. Nutrition levels can also affect the berry size. And then crop load influences berry size as well. High loads of clusters or berries will produce smaller berries. So even within the cluster, if there are less berries, there's less fruit set, then you will get larger berry size. If you have more fruit set, you will get smaller berry size. Now, is this important? Yes, particularly if you're considering quality levels. It's generally considered that berries of smaller size have more flavor. And the reason for that is you have most of your flavor coming from the skin of the berry, and that has a larger surface area to volume ratio with smaller berries than it does with larger berries. Therefore, you get more flavor per amount of juice. So finally, how do we end this? How many buds should you leave when you're pruning? And this again depends upon your variety that you're growing and the vigor of your vine. A more vigorous vine you can leave more buds on. A less vigorous vine, you're going to remove more buds. So the number of buds can be determined by the amount of pruning in the following way. So severe pruning is considered something where you have less than 20 buds per vine. Moderate pruning would result in 20 to 70 buds per vine. And light pruning would be that you are leaving greater than 70 buds per vine. So in our region, we aim for approximately 16 buds on 8 spurs to get the best fruit quality. This would be called severe pruning, but I would say it's optimal pruning for our area. The reason for that, in part, is that we have a shortened growing season, and also our conditions are more severe, particularly regarding winter. And so if we have too much fruit on our vines, it taxes the vines. It reduces the amount of carbon that can be stored in the trunk and the roots to help the grape overwinter during the cold season. And it improves the cold hardiness of the vines. So if you have too many fruit on your vine, you're going to maybe not lose anything in the first year following, or even the second year, but by the third year, you will start to see reduced yields in your vines and perhaps an increase in vine death as a result of a reduced cold hardiness. That's it. I hope you enjoyed this rather dense video lecture, and please feel free to like it, visit it again, and subscribe to my YouTube channel for Nevada viticulture and wine. Goodbye.